I just rewrote this first equation down here, log tangent x equals m, and then you undo the log with 10, power of 10, base 10. Okay, so cotangent is 1 over tangent, so it's basically the reciprocal. All right, so cotangent of x equals 1 over 10 to the m. You just flip that, and that's 10 to the negative m. Cotangent x is at 10 to the negative m. So if you take the log of both sides, log of the cotangent of x equals the log base 10 of 10 to the minus m. You can bring this minus m out front, so you get minus m log base 10 of 10, and this right here, this equals 1, so you just get minus m out of that.
Oh, 10 of 10. Oh, I forgot about that rule.
So letter B. Yeah, I mean these are good questions. These are really good questions.
On to number 3.
Okay. Number 3. All right, evaluate. So, all right. Okay, so this first one here is absolute value -2 minus 3 plus 5. Okay, so we're just going to deal with what's inside parentheses first here. This becomes 2. This becomes -4, and then that becomes 4. And then we got a plus. Okay, and we're going to deal with all this over here. So it's 6 minus absolute value -2 plus 4. So this becomes 6 minus 2. The absolute value becomes 2 plus 4. And then you combine these. So 6 minus 2 is 4, plus 4 is 8. So plus 8 equals 12.
Alrighty.
Yeah, I know you chatted me. Let me see if I can get this up. Well, I've got to do them all. Okay, well, that's easy. 4.
All right, this one I have no idea how to do.
Circle is inscribed in triangle A, B, C. A line is drawn, vertex A to the point of tangency M. AB equals 5, AC equals 6, BC equals 7. How long is BM? And no multiple choice now. All of a sudden I want some multiple choice. Oh no, they're down there at the bottom. Okay. All right, the line is drawn, vertex A to the point of tangency. If AB is 5, AC is 6, and BC is 7. How long is BM? All right, so I think this is one of those workaround problems, maybe?
Yeah.
I don't know, I'm not really sure. So let's call this X. So then this right here is 6 minus X down here. This is 6 minus X. Okay. And this is where it gets a little tricky. So if we call this Y, I'll call this Y in here. We know that Y plus 6 minus X equals 7. So Y is equal to 1 plus X. Just if you subtract X, 6 and add X, add X to both sides. And then 1 plus X here. And then we do the same thing here. We call this Y. We know that 1 plus X plus Y equals 5. Okay, so Y is equal to 4 minus X. So we replace that. And then 4 minus X. So now these have to be equal. That was the point here, is any of these points of tangencies are equal. So 4 minus X has to equal X, and that means X equals 2. So now we can start throwing in some numbers. Let me change colors here because that will help. See this, 2, 6 minus 2 is 4. That's 4, X is 2, so that's 3, and that's 3. And then there you have your answer, BM is 3. So these are called walk around problems. They're from geometry.
Okay. Why do we end up like turning into like 1 plus X and 6 minus X or whatever? How did we come up with that?
Okay, well, I just picked arbitrarily, I chose this to be X.
Oh,
And the whole
Oh,
distance, the whole thing is 6, so it's gotta be 6 minus X, and then this has to be 6 minus X. And then the whole thing is 7. So these two things have to add up to 7, and that was the work down here. I called it Y initially. So it's Y plus 6 minus X has to equal 7, and then you solve for Y.
Okay, so BM ended up being on the number 5. The root of the equation, x cubed minus 5x squared. Do you see as 5 squared or
Yeah,
5?
it's equals 6X. Yeah, I do see that. Let me, so we got number 5 here is x cubed minus 5x squared equals 6x. So you want to move everything to one side.
Yeah.
And then you want to factor out an x. And then you have to factor this. So this is two numbers that multiply to 6, but add up to -5, x minus 6, x plus 1. And then you get your 3 roots here.
Here. Wait. Oh, okay.
So you get x equals 0, x minus 6 equals 0, x plus 1 equals 0. So x equals 6.
Oh, I see what you mean. 0, 6, -1 is. That's just B, right?
Yeah, it looks like it. Is this for a grade or is this just to like see how to do it?
Or just for practice.
Yeah, I figured. So
They'll be grading it, but for now, it's just kind of for practice. So I just kind of want to understand this the best I can.
So this one, you have to look at the answers to know what to do, because you're like, what do I do here? So the answers basically say, this says to solve this for X. Okay, so you're like, well, how do I do that? Well, you gotta take this thing I circled, and you gotta multiply, you gotta cross multiply here. So you get K minus 3x equals M minus 2x, and then you gotta solve for X. So if you add 3x to both sides and you subtract m, you get k minus m equals x. And there's your answer.
Oh, that's more than I thought it would be.
It is, but because it's symbolic, sometimes it's like, what do I do? Or so on. 7's weird.
Oh yeah, I saw this and I had no idea what to do.
Yeah, and see the thing that I got to get you to see is like, if it didn't have this right side here, would you know to just rationalize the left side?
What'd you say?
Would you know to rationalize the top and bottom, the left side here?
I think so.
Like if you were to, okay, I'm just going to multiply square root of 5 plus square root of 3.
Oh yeah, like by the inverse.
Like that's kind of one of those things you hopefully you picked up here. The top you FOIL, so you get 5, and then you get square root of 15, square root of 15. So you get 2 square root of 15, so you get 2 of them, plus 3 over. Okay, this ends up being FOIL, and the outer and the inner cancel. So you just get 5 minus 3 on the bottom here when you do that. So this equals 8 plus 2 square root 15 over 8. Okay. And then you divide both of them. Like that's totally reasonable. So it's 1 plus 1/4 square root 15. And then we go back to the original question. The original question says equals square root of 15 divided by x.
All right, just trying to catch up real quick here.
Sure. Yeah, I'm sorry. And this probably, it goes so fast.
Over. All right, is that the end of it? Or?
No, we haven't solved it yet. So that's the challenge here. So I'm gonna do some. I'm gonna do something here. I'm gonna multiply both sides by 4. What's that?
Oh, we start with 4.
So I get 4 plus the square root of 15 equals 4 square root of 15 over x. Just to clear that out a little bit. And then to get x, you got to cross multiply here. So we have x times 4 plus square root of 15 equals 4 square root of 15. Right. And then you divide both sides with 4 plus square root of 15, 4 plus square root of 15. So we're really close, but none of those are the answer because you have to rationalize the bottom yet again. So you have to multiply the top and bottom by 4 minus square root of 15.
That's a 4 plus root 15 on the bottom?
Yeah, 4 plus, it's the same as this, yeah.
Okay.
All right, so on the bottom, believe it or not, you just get 1 because it's 16. It ends up being 16 minus 15. You get 1. On top, you get 16 square root 15 minus 15. I wonder if that's not the right symbol. I saw a division there. Maybe it meant minus x. Huh. Sorry, I'm trying to figure out what the heck this thing, if that's a division. I'm looking up in the original. Is that really a division symbol? It's really weird.
Oh, that's
Plus?
a plus symbol.
Is that a plus?
Yeah, it's a plus.
Oh, well, that changes everything. All right, well, we got to go back and clear some of this out. So we got up to this step here. Equals square root 15 plus x.
Okay.
So if I multiply both sides by, well, okay, so it's like, how do I get a 1? Like see how this just has a 1 there for that?
Yeah.
So if I kind of just, well, let me just multiply both sides by 8. That'll be clear. So now you've got those cancel. 8 plus 2 square root 15 equals 8 square root 15 plus 8x. Okay. And we're really close here, but these need to match.
Oh, all right.
All right.
So,
And I'm still not seeing this. Are you sure that's a plus? I don't know. I'm gonna suggest we move past this one because everything we do depends on that operator right there.
I have the lecture notes on here. I think she gave the answer to it. Let me check my camera roll real quick. Number seven. I can't really make sense of it, but I'll send it to you and see if. Sending a photo to you.
Okay, I'll take a look here. Oh, you know what? I made a mistake here. This is 2. That does change this. That does change this. Okay, I'm sorry. This now it does work. I made so many mistakes on here. That's why this. Okay, so when we divide by 2, both of these,
Yeah.
this actually works. So you get, I can't believe this. You get 4 plus square root of 15 equals square root of 15 plus x, and then you just undo this. You just subtract square root of 15. So you get x equals 4. So I didn't subtract. For some reason, I added, and that was the mistake. So sorry about that. Okay, number 8.
Root 15 plus x.
All right, for what and only what real values of I will this work? So you have to solve this thing. You move this over, so you get square root of 25 minus t squared equals minus 5. You square both sides, you get 25 minus t squared equals 25. And then you end up getting t equals 0 for that, because the 25s cancel, and the only thing that works there is 0. Oh, it's his values of t. So the only value of t that'll work here is 0, but you have to check your answer. Okay. Now I could have done this another way, and this is probably the better way. If I go back to the original, actually this line right here, is the square root of anything ever negative? Can a square root ever be negative? And the answer is no.
No.
No, because this has to be written. So this has no solution. So even though you do all this work and you think you've come up with something, that's why this one is here.
Oh, wait. Wait, can we backtrack real quick? I couldn't really understand what was happening there.
Well, you can just solve, the left side is just solving it as if you don't understand.
Yeah.
And you get an answer, but the problem is when you check it, it doesn't work. And maybe that's where you're like, what do you mean by that? So let's check it. Let's check. 5 plus square root 25 minus 0 squared. 5 plus square root of 25 is 5 plus 5, which is 10. Is that 0?
No, that's not.
No. So more generally, what I was trying to tell you is that the square root is never negative. Like if you look at the graph of a square root, it's always up here. It's like asking the absolute value of a negative number, or can the absolute value function ever equal a negative number?
Oh, yeah.
The answer is no. And this is the same thing. Can you ever take a square root and get a negative number? No. The answer is no.
And if you have a negative square root, it doesn't work, right? What happens when
Well,
you have?
you could. I mean, if the problem said 5 minus square root 25 minus t squared equals 0, this works.
Yeah, but you can't have a negative square root in the actual square root, right? You can't have that.
You can't take the square root of a negative number. So like the square root of 4 is 2. The square root of negative 4 is 2i, which is imaginary.
Oh yeah, I forgot about the imaginary numbers. I need a little refresher on that. All right, so this would just be a no values.
That's right. 9, I would just recommend looking up, because these are just definitions. So the one that is not true is the one that's false, not a definition. And we moved to 10. It'd be my recommendation.
Fun word problems again.
Yeah.
All right, let's move on to 10. A swimming pool has 2 inlet pipes. I don't understand these word problems. I don't know why.
Well, they're tough. They're tough here. So there's a pool, and there's pipe A, and it does it in 3 hours. So there's a rate associated with A. So this D equals RT. It actually applies to these. It's really total quantity equals rate times time, whatever the total is. So in this case, your T is a full pool. So a full pool is your rate, your A rate times 3 hours. Or if you use inlet pipe B, your total rate, your total full filled up pool is rate B times 4 hours.
Okay, simple enough.
Okay, a third outlet pipe, okay, can empty the pool in 1.5 hours. That's interesting. So the C over here, its T is RC times 1.5. Okay. If the pool is only half filled, okay. How long will it take to empty or fill the pool? So 1/2 T, half full, and it's this in minus out. Kind of thing. And all three pipes are open simultaneously. How? Oh boy. All right. So the N is, wow. They usually give the rates.
Yeah, but they like want you to do it all from scratch, basically.
Yeah, if the pool's only half filled, huh? Now, I generally don't recommend this, but let's just assume that T is 12.
Alright.
Okay, so if T is 12, the rate A, is 4, because 4 times 3 gets you there. So the rate A more generally is T divided by 3.
Okay.
Okay, and that's going in. So you have T over 3. And then over here you have plus T over 4 minus, because the one going out, T over 1.5. And this is equal to we don't know, I guess. So let's see what these add up to. This is where it's a little bit awkward, I guess, is we need to make a common denominator. So let's make it it ends up being 12. So this is 4T over 12 plus 3T over 12. And then to get to 12 here, you multiply by 8. So you get, 8T over 12. So notice that when you add these up, you get minus T over 12. So that tells you that the pool is like more of it's going out than going in.
Okay.
So that means it's going to empty. And I don't know, maybe it's clear that E, which is 12 hours to empty, is a reasonable one there. Because of this 12 here.
How do you get the negative T over 12?
Actually, it might be 6 because it started half full. Just adding the numerators, 4T, 3T minus 8T.
Oh, never mind.
So it would take 12 hours to empty. So this is where it would take 12 hours to empty if it was full, but it wasn't. It was half full, so it's only going to take 6 hours. So that's my mistake there. It would 6 hours to empty. I'm having a lot of, I'm struggling to really zoom in on 11 enough to be able to see what that last one is.
Last one, the 4 3/4.
No, I mean, in the series, it says 6 1/4, maybe 4 and 1/6, 2 and 7/9. I don't know what the last one is. That 12 and
Yeah, that's some really bad printing on their part.
I don't think we should do that one. So let's
Yeah, I can't read that either.
let's do 12 here. Okay. All right, D varies jointly as R and T. So D equals K times R and T, R times T. That's what this first sentence means. Jointly means that they're multiplied together.
Oh,
Okay. All right.
so it's basically a 2R and 2R and then KT. Is that how that goes?
Yeah. So like, let's just you can imagine here. Like they don't want you to do this, but you could pick numbers. But if R is doubled, that means R goes to 2R. So that's 2R. And T is trebled, which I guess means tripled. So T goes to 3T. So if you multiply these together, you get 6 RT, and then you move the 6 back. So you get 6 KRT. And I don't think you did this that much in your physics class, but a lot of times physics classes, they like ask these questions where like, how much more is this than the original? And it's 6 times.
Wait, how'd you get the 3T again?
It said it's tripled.
Oh, it's treble. Oh. I didn't know that treble meant 3. Should have
Not sure either. I think it does, but
straightforward. On the number 13. Once again, I forgot how to do these. Did we do these in algebra or something?
algebra 2, I don't know, they cover them over and over again. So the thing is you're not used to questions being this difficult, or this direct. So so the first one here, 2 to the x, 4 to the x, you can rewrite 4 as 2 squared. So this is 2 squared to the x. Okay. So and then you can multiply this, and so this becomes 2 to the 2x, 2 to the x. When the bases are the same, you add the exponents. This becomes 2 to the x plus 2x, which is 2 to the 3x. Now you might be saying to yourself, well, none of those are there. That's right, because you can do 2 cubed first to the x, so it's 8 to the x. But it's a lot of manipulation, a lot of understanding, how to combine these things.
Oh. All right. 2, 2. Okay, I see you did. So the answer to this would be A for 13.
Yes.
Awesome. On the number 14, which one of the following is not a perfect square?
So the test for a perfect square is the following. You square root the first term. So we'll look at A. You square root 16x squared, and you square root the last term. So here you get 4x, here you get 1. You multiply them together, so you get 4x. Then you double it, so you get 8x, and it can be plus or minus. So this one satisfies. This one's good.
Oh, wait, say that one more time because of
You have to take the square root of the first term and the square root of the last term, multiply them together, then double it. And if that matches the middle term, you're in good shape.
oh, so this one doesn't match it.
It does. It's minus 8x.
Oh, okay.
So let's look at B. You take the square root of the first term. You take the
That's
square root of
right.
the last term. That's 3m. That's 5n. You multiply them together. That's 15mn. Then you double it. And then plus or minus. So is that there? Yes.
Yeah, it's there. All right. On the C.
C. You take the square root of the first term. Square root of the last term. You get 1 and y. You multiply them together. Then you double it. So that's 1y doubled is 2y plus or minus, you go back and look and you say, oh yeah, that's there. D has the wrong form. So you will never see perfect squares in this form. So perfect squares have the following form: a squared plus 2ab plus b squared, or a squared minus 2ab plus b squared. So it's either going to be plus plus or minus plus. D has the wrong form. It's minus minus. So D is your answer for that.
On to number, what is it, 11 now?
We're up to 15 here.
Oh, 15? All right.
15, yeah. The tens digit of a certain two-digit number is represented by X and the units digit by Y. The number exceeds its tens digit by 34. This leads to the equation. Okay. So they're saying that like let's say the number was 57. They're saying X is 5 and Y is 7. You follow that? Like that's what it means by that and that.
And I think I kind of understand it.
Okay, so that to get to this number, to get to 57, it's 10 times X plus the Y value, because X is 5 and Y is 7.
All right. So then we replace this.
Yeah, so now they're telling you this. They're saying the number exceeds its tens digit by 34.
Oh, all right.
The number. So they're saying whatever this is. So we're going to call this Z for a moment. So Z equals 10X plus Y, but they're saying that Z exceeds the tens digit, which is X. Z is exceeds the tens digit by 34. So Z is equal to X plus 34. That's how we're like converting that sentence into this. The number is Z in this case.
Oh, all right.
And the tens digit is X, so it exceeds it by 34. So you substitute that in. You say, okay, that goes in there. So X plus 34 equals 10X plus Y. And then you got to figure out, well, which of these equations is it? If you subtract X from both sides, you get 34 equals 9X plus Y. It looks like it's letter D.
Excellent. Number 16.
On to number 16. This one you should just check your answer and just see if you understand it. It's just a definition. Let's go to 17. All right, X varies directly as R squared and inversely as S. So it's saying X varies directly. So that's K R squared, but inversely as S. So inversely means it goes in the bottom. Directly is on top.
All right.
Okay, so it says if R is multiplied by 2, so they're basically saying R goes to 2R. That's what we did in previous problems. So let's put that in. X equals K times 2R squared over S. Okay, so this becomes this becomes 4r squared. So it's 4k r squared over s. So let's go back and see what the question is asking, because it says, what must s be multiplied by in order that x remain unchanged? So they're basically saying, like, do you see how what I've boxed in is in the original? That's the original. That's the original. That's the original.
Oh, I see.
Okay. Now this is the original, but we now have this 4 here. So what does s need to go to so that the 4's cancel out? It needs to go to 4s.
Okay.
And that's how you get your answer of D.
Okay, that makes sense.
But we're probably not going to get through all of these. So if you want to pick and choose up to 25, which ones we do, we might, but
Just avoid big word problems. That's it.
all right. Well, 18 is a word problem and 22 is a word problem. So we can start with those two.
Okay.
All right. If 15 men can pack 360 boxes in 4 hours, how many men can pack 540 boxes in 3 hours? Okay. Okay. Okay, so this first thing here, we got to kind of unpack this. So the 15 men are doing 360 boxes in 4 hours. They're doing 90 boxes in 1 hour. Okay, so I just divided both of those by 4. So that means that one man, if you divide by 15, is doing 6 boxes in an hour.
Oh, all right.
I think, boy, no, it's, if I divide that by 15 and one man is doing 6 boxes in 4 minutes. Because if I multiply that by 15, no. Oh boy. And how many men can pack 540 boxes? The job is a box. So 15 men are doing 90 boxes in 1 hour. Okay, we can do this. Sorry, let's back up here. So again, if you divide by 4, you get 15 men. They're doing 90 boxes in 1 hour. Okay, so in 3 hours, though, if you multiply these by 3, in 3 hours, they're doing 270 boxes. And how many do we want?
We want 540.
540. So since you can't change these, you can only change this one. So if you double it to 30 men, you get your 540 boxes.
Ah, all right.
You have to, this isn't quite the right way to do it, but I guess it's, there's a jobs at the rate equation that I don't have. So yeah, we'll all right, so we said word problems here, so let's go to number 22. I guess 24 is another word problem, so we'll be able to get to that one. And I noticed there's no trigonometry. There kind of was in that cotangent problem, but okay. 4 tractors working together can plow a field in 12 hours. All right, so 4 tractors working together can plow a field in 12 hours. How many hours will it take 6 tractors to plow a field if of the same size, if all the tractors work at the same rate. All right, so 4 tractors, 12 hours, and 1 field. So if we divide by 4, 1 tractor in 3 hours can do 1/4 of a field.
All right.
1 tractor, 3 hours, 1/4 of a field. But we have 6. All right, so if we multiply by 6, we get 6 tractors, 18 hours, and they're doing, and we're multiplying everything by 6. So we get 1.5 fields done. So basically we took too long, like we didn't have to go all the way. So we end up taking 2/3 of this number. So this is like 3 halves. So 2/3 of it and 2/3 of this, but that gets us back. Yeah. There's something not quite right here. Pod field in 12 hours. How many hours will take 6 tractors? Pod field the same size. Rate and time. I want to say it's 12, but can you check if the answer is E for this one? If you got the answers.
Oh, I don't have the answer for this one though.
Oh, okay. Well, I'm going to say it's 12 hours. That's not right. No, it should be faster. Well, it has to be faster because they've got 6 tractors instead of 4. So, each tractor. Okay, so maybe we're doing this the wrong way. Let's look at this one more time. So in 1 hour, it doesn't work. 1/12 of the field in 1 hour. 4 tractors is 1/4 of the field. So if we want 1 field and we have 6 tractors, it's not going to work. Yeah, I don't know. I'm sorry. We're gonna have to just move past this. There's something here that I'm not seeing right away. So let's look at number 24. All right, if each edge of a rectangular solid is doubled, the total area is multiplied by. So the edge of a rectangular solid, I think it means something like this, since it's solid. Okay, so this is X, Y, or length, width, and height. So the volume is length, width, and height. Okay, but it's not asking about that. It's asking about the total area. So that's probably your surface area. Your surface area of this is 2 length times height plus 2 length times width plus 2 width times height. So basically it's 2 times LH plus LW plus WH. So you just factor a 2 out of each of them. So, but now they're saying like, oh, L goes to 2L and width goes to 2 width and H goes to 2H. So you substitute those in here, you get 2L and 2W plus 2L, or or H, I'm sorry, 2H plus 2W plus 2W and 2H. And so when you get all these, you get, oh, it's 4LH plus 4LW plus 4WH. So this 4 can come out of each of them. And that's that number that they're looking for. That's what the total area is multiplied by. So I think we could do question 23 or 25 if you had a choice.
25.
25 here. All right, if R equals KT squared over 3 over K, I guess I do need that, then T equals, so it's basically saying to solve for T. So whenever you have a fraction at the bottom, you flip it. So it's K times KT squared over 3, excuse me. So that's K squared T squared over 3. Multiply both sides by 3 to clear it. So 3R equals K squared T squared. And then you take, you're solving for T. So bring this K squared over, divide both sides by K squared. So you get 3R over K squared equals T squared. And then T equals the square root of 3R over K squared. And you'll notice like none of those answers are there, but you can take the square root of the top and the bottom. And the bottom becomes just K. All right, well, I think that takes us to the end of our lesson here tonight, Jack. I apologize for not getting to all of them. Hopefully you can ask your instructor.
Thank you so much.
Yeah,
Appreciate
have a great night. I'll see you next time.
it. See you later. Bye-bye.
Bye.